I'm just going to do some examples right out of the book, just to get us into this new chapter, Chapter 4, and talking about polynomials, getting familiar with some of the stuff. First of all, I think I'll just show you the page. Let me see if that'll focus a little better. Okay. Let's zoom. Let's try the zoom here. I haven't tried this yet. Ooh, look at it zoom. Okay. That's pretty good. Okay. It'll help if you have your own book as well, looking at this. So, let's look at just the very first of the oral exercises. It's about some terminology, but it's very important terminology to be able to look at the pieces of a polynomial, and the individual pieces are called monomials. Mono being one, and poly meaning many. And to identify some of the important features of that. So like number one here, they say find the degree and the coefficient. The degree is the power, the exponent you see on the x. So this is something times x to the fourth. That's going to behave in a really, really different way from a number times x squared or a number times x cubed or anything different. And so the degree is the most important thing. Now the coefficient is important because 3x to the fourth is going to be different from 2x to the fourth or minus 5x to the fourth. It's not going to be so qualitatively different, but it's certainly going to be nice to be able to talk about that number. We need a name for it, and that's the coefficient in front of it. Here, number two, it's when there's no exponent visible, it's t to the 1 power. We just don't write that usually. T to the 1 power is t multiplied by itself just one time, and that's just t. And so we don't write it, but there's still a degree there. It's still 1. And the coefficient is minus 1, even though we're not writing minus 1 explicitly. And here's another case where we wouldn't write something explicitly. Here, the coefficient in front of x, y squared, z squared. Here, there's 3 variables. That can get pretty darn complicated. But there's no number written in front of it. Well, there really is a number hiding there. It's 1. So we do have to watch out for things like in number 2 and number 3, where there is a coefficient. It's just equal to 1. Or there's a power, like the degree of x in this polynomial is 1. But when they say the degree of the whole monomial, that's going to be the combination. It's 1 plus 2 plus 2. If I wrote this out, it would be x times y times y times z times z. There's 5 variables, five things multiplied, 5 variable quantities multiplied together. And so the total degree is going to be 5. We don't work a whole lot with polynomials in more than one variable in this class. And it can get really complicated to do algebra with lots of variables. But we do need to be able to talk about it at least a bit. And it's not a lot harder as long as we keep track of some of the bookkeeping. 4 is another good example. This is definitely a good trick question. That it's tricky, but it's not an artificial trick. It's the kind of tricky thing you definitely want to be able to recognize. There's no variables in this expression. Even though it's evaluated, even though it's written as 2 to the 3rd power, 2 times 2 times 2, there's no variables here. So it's a monomial. It's a polynomial. It's just an incredibly simple one. It's really the number 8 times x to the 0. So that can be confusing. If you're just doing this typographically, and that's the way your subconscious tends to do things, it'd say, oh, okay, the exponent is 3. That means the degree is 3. But there's no variable quantity being raised to the 3rd power here. And another way to think about it is you just want to look at this and you say, can I simplify this? Can I actually do the arithmetic in question? If you look at 3x to the 4th, if x is a variable, if it's an unknown, you can't do anything with that. It's just 3 times whatever that is to the 4th power. You really can't do very much with that. But here, the 2 is a known number, and you can actually go ahead and take 2 times 2 times 2. It's just 8. And so it's a constant, and that's really, we want to think of that as something times x to the 0. And so that's going to fit into this framework of coefficient and degree, but it's actually 8 for the coefficient and 0 for the degree. Let's just do one of these, name the similar monomials thing. Let's do 7. Here it's a lot of stuff with a bunch of different variables. There's 3 different variables, x, y, and z, and we're just trying to see which of these could we group together. And that's just a matter of looking at the degree of each of the x and y in each expression. So 6xy, is there anything else with just one x and one y and no z's? This one you might think, oh, that has an x and a y. But that's not really similar because it's got 3 variables. That's, again, a big qualitative difference. Aha, but this is just a number times x times y. That's a number times x times y. The way you can really test that is if you have 6xy, I'm zoomed in. Well, okay, as long as I remember that. You have 6xy plus minus xy, those two things. Can we actually collect those together? Well, yeah, because they both have exactly the same common factor of xy, and that's a 6, and I add that to a minus 1, well, that's just 6 minus 1, and that's going to be 5xy. I could not have done that. If this had had a z in it, I would have had a z in here, and I couldn't have just done arithmetic here and collected it together. It's only because they had exactly the same variables to exactly the same powers and nothing else, and they just had different coefficients. So they have exactly the same degrees in terms of all the variables, but possibly different coefficients. That's what makes them similar monomials. Let's see. Let's go back to, okay. So the 6xy, the minus xy are similar. 2yx over 3. That looks very different typographically, but it's still the number 2/3. You can just separate it out in terms of the number, the coefficient part, and the variable part. It's the number 2/3 times, let me zoom in a little more maybe. There we go. Focus that puppy. It's the number 2/3 times y times x. The order doesn't matter. X times y is the same as y times x. And the fact that it's written as a big fraction, that doesn't matter because you can really rewrite it as 2/3 times x times y. So these guys are all similar. Similarly, minus 4xz and 4zx. In fact, if you add those, they're exactly the negative of each other. If you add those, you get 0. They definitely simplifies. And then another one, xz over 2. Just an x, just a z. The yz here, that's not similar to anything else. Then the minus zxy, the 2yzx, those are similar to each other because they have one y, one x, and one z. And again, the order does not matter. So let me just skip. I just want to keep this at 10 minutes. This one's not too hard, just to read things in order, in the right order. Let's do one of these exercises. Let's do exercise 18. Let me zoom out a little bit. Okay, and focus again. Okay, so number 18. We're going to take u squared minus 6u plus 7, and they're asking us to add them together. We're going to add that to u squared plus 6u minus 8. And what we're going to do is we're going to group like terms together, similar monomials together. Doesn't matter. When you add things together, it doesn't matter what order you're doing it in, as long as you're very careful about minus signs. And so I'm going to group the u squareds together. I'm going to group the u's together, and I'm going to group the constants together. Well, that's 2u squared. Well, that's kind of nice. Those canceled, and that's going to be very interesting. And then that's just a minus 1. That might be something very useful to us. It can be very useful when you add two things together. These both had 2 u's in them. This only has u mentioned once. That can be a really huge simplification sometimes. Okay. Now what about, so that would be part A. What about 18b? When we subtract them, what we're going to see is a different thing cancels. I'm going to collect it together again. When you get more practice with this, you can definitely streamline this, but I want to do it really carefully. I'm going to even do it, yeah. So u squared minus u squared. It's really important that this minus is distributing into everything. Minus 6u, and then another minus 6u. And then a 7, and a minus 8. And if you're pretty comfortable with writing that immediately as plus 8, that's fine. But that's what's going on. And if you miss that minus sign, that can be deadly. And the big mistake here usually is not to write these parentheses in the first place at all. And then you're going to think of this as minus, but you're going to forget that this, you're going to write this as a plus and forget that it's really a minus, because you're subtracting all 3 of these things in this whole group. And you're going to forget this as well. Let's cut to the chase here, because I got to finish. So minus 12u plus 15. Alrighty, time to stop.